repetitions with gaps in between cycles. In the previous session, you have seen how to add repetitions which should occur consecutively. It is also possible that you can specify a repetition which can come in between multiple clock cycles. That means there could be a gap of multiple clock cycles in the repetition of this expression. So these are the non-consecutive type of repetition operators. There are two types in Systemverilog assertions, which are Goto repetition and non-consecutive repetitions. You specify a Goto repetition type of repetition using this symbol and a non-consecutive repetition using an equal to symbol. Both Goto repetition and non-consecutive repetition are similar in nature. Both of them are used to specify repetitions with gaps in between them, and there is one big difference between these two which we'll learn in this session. First, you will learn Goto repetition operator. So this is how you specify a Goto repetition. So let's see this example. Valid hashers to ready, and to ready expression you are adding a Goto repetition of 3. So it specifies a repetition of 3, but these 3 repetition of ready need not be coming consecutively. It could come with any number of cycle gaps in between them. So try to elaborate this expression without this repetition operator, or just by using cycle delay operators. So if you try to elaborate, does it look like this expression? Say valid hashers to ready, then between 1 to $, cycles ready should be high, and again between 1 to $, cycle ready could be high, and again between 1 to $, cycle ready could be high. Does this second expression is equal to this first expression? The answer is no. Think about this expression. Does this expression say something like that the ready could be high 3 times with any number of gaps in between them? It is not, because it is not specifying that the ready could be going low in between them. So to say that the ready could be repeated 3 times in any number of cycles with any number of gaps in between them, so you should say that the ready can even go low. The ready may or may not go low. So the correct elaboration of this Goto repetition operator will be something like this. So it will be equal to valid hashers to node ready, which is repeated from 0 to $, cycle, followed by 1 clock ready. So this whole expression is consecutively repeated 3 times. So this is equivalent expression of this Goto repetition operator. By adding this whole set of condition before ready, you are saying that this signal, the ready signal, could be going low from either from 0 to infinite number of cycles. So this is equivalent of this Goto repetition expression with consecutive repetition expression. And if you again elaborate this expression without this consecutive repetition, it will look like this. This we have seen in the previous session. So this is the equivalent expression of a Goto repetition operator. Now if you don't understand this, let us try to draw this waveform, and you might understand better by looking at a waveform. So this was the original Goto repetition expression, and this was equivalent consecutive repetition operator for this one, and this is the elaborated expression of these two. And this is a waveform that is drawing or satisfying in all of these conditions. All 3 sequences are exactly the same, specifying exactly the same behavior. Now let's go through the waveform and see whether all of them are satisfying them. So the valid is drawn 1, and we look whether all of these ready signal will satisfy these conditions. So the first one, valid is going high, and after that, you in any of this expression you are not saying anything about the valid. So after 1 cycle, the valid may or may not go low. So we are not specifying anything about valid here. So that is why it is shown either as 0 or 1. And after valid is going high, after two clock cycles, ready should be asserted. So after this point, after this 2 clock cycle, ready is asserted. So we can see that all of these these are starting ready at this point, but the fourth one is not starting ready at this point. So this is a violation of the first property itself. So the fourth expression will not, the fourth waveform will not satisfy this assertion. Now let's go through the first three. In the first case, the ready is continuously high for three clock cycles. So let's see whether this whole expression will satisfy there. So if ready is high, continuously high here, so it will satisfy 0 here, and hash 1 ready will be coming at this point. And again, after 1 clock cycle, the ready is saying ready could be high for 0 clock cycle. So it is again taking the 0 condition and saying ready is high here, and it is repeated. So this will satisfy this first expression. And if you see the second waveform, the ready could be high 3 times, and there could be any number of cycles in between them. So this will also satisfy this expression. And say if ready is going high for continuously 2 clock cycle, and after a infinite number of cycles, if it is again going high for a single clock cycle, this will also satisfy this expression. Thus, in Goto repetition cases, the repetition could happen with multiple delays in between them. So, or non-consecutively, the repetition could happen.